So at 𝐕𝐚𝐥𝐮, we like to call us that we are the smart data platform behind the development of these circular industry business models and value chains. So one of the big things that we are tackling is, of course, this underutilization of the byproducts and waste streams. I won't go too much into detail because this is, I think, something that was covered many times already in this conference. But why are we focusing on this? Because we see that especially in the field of, let's say, valorization of bio-based byproducts and bio-based, let's say, inputs can have a very significant market opportunity in the next years, which means that a lot of, if we say there is market opportunity, it means that there will be funding available for it, which means that these are the solutions that we should promote and find those that will result not only in the economic positive impacts, but that will also show in the real climate impacts that we are all working towards. We also have here a stat line in terms of one of our early customers of 𝐕𝐚𝐥𝐮, that they were able to find and validate opportunities that help them to reduce their Scope 3 impacts by over 200,000 tons of CO2 a year. And I think that this really shows, the drastic potential of these bioeconomy solutions in industrial setting, in real, let's say, in real scale that we are working towards. So as 𝐕𝐚𝐥𝐮, as I mentioned, we are an AI and data company working on the analytics of various material streams so that we can start facilitating really at scale the development of many cradle-to-cradle approaches. We are mostly working right now in Germany, but also in a few other countries across Europe. We have a database of 3.5 million companies and over 400 circular value chain solutions, which enable us, to really find and fine-tune the material flows within either supply chains or within regions. So the baseline of our work is our algorithm that we call 𝐵IOLINK. So 𝐵IOLINK is our algorithm that understands the connections between various material streams, as well as new novel technologies and processes. And this all together and brings it all together so that we understand how certain companies or certain material streams or certain regions can prioritize the various different solutions or bioeconomy, let's say, innovations for their specific case. It includes the 𝐵IOLINK algorithm, includes everything from the types of companies that can be involved in this to the specific technologies, as well as the climate impacts and all of the other factors that can make, let's say, the key success factors that can make these innovations possible or not. Okay. And here is just an example of a 𝐵IOLINK model, although I will show you then live in 𝐕𝐚𝐥𝐮 how it actually works. So, as I said, we work on two different aspects. So one are regions and municipalities, the other one are industrial supply chains. But today I would like to present to you how we are working on the regional and municipality levels. So the first point of our work is that we have this very big database of many companies, on top of which we can lay our prediction algorithms to understand where certain material flows are happening, in what scale, what size, and based and as well, let's say, product requirements. So as it was mentioned, let's say in the previous by the previous speakers, for example, in a region, maybe you have lots of pharmaceuticals or you might have lots of chemical industry. So your biomass should be directed into producing the specific ingredients or specific products that can be sold to those regionally significant companies. And by having this understanding of the material flows and market requirements, we get a very, very good detailed map for prioritizing the solutions moving ahead. And here is where our 𝐵IOLINK engine comes into play. So we have then the calculations and all the analytics and all the computation which is necessary to define various different opportunities for a specific region, but also to evaluate the potential of them so that we understand, okay, what is the biomass availability for that specific technology or process, but also what is, let's say, the market potential of a certain new bio-based product for the intended markets. This way, we can really quickly prioritize and evaluate the different investment opportunities so that either regions or, let's say, municipalities can develop very concrete action plans towards implementation so that we are not being stuck in the R&D, but that we can follow the good examples demonstrated earlier towards really industrialization of these new processes, which will in turn result in successful impacts. So here we provide both, let's say, user accesses, but also provide the, let's say, the services for data interpretation and support in the development of these action plans. The last step is that for all of these, let's say, prioritized solutions, we have to validate them. So theory is theory, but we have to get sort of insights from the concrete industry partners in the specific region. So here we are facilitating, this secure data sharing between the companies in the region. So maybe you have a case surrounding breweries to collect data around their current byproduct and waste management practices, about their current projects that they are doing, but also, to share data that is necessary to develop and coordinate these new development projects, where it might go into more technical details like compositions and chemical analysis of these specific material flows. It also then gives the, let's say, the regional developers like a very good overview of what is happening in the region and where the next, let's say, policies and investments and action plans should really be focused. So here is, for example, one example that, again, that I found for these aquatic ecosystem cases, where it was, valorization of the brewery byproducts, where the value of this additional conversion increases the value that the brewery is able to achieve by 110%. So having a very much economic driven focus for the brewery to divert the existing spent grain application to the new project, as well as that by diverting it to another market application, they are reducing their footprint related to the waste and byproduct management by 83 times. So that is not 83%, that is 83 times through the impact that this can have in the specific process. So I invite everyone to also, to schedule a call where we can have a more detailed discussion about how this can apply to see how we can maybe support your activities towards either going towards the industry, finding industry partners for your R&D innovations, or also to find the innovations and possibilities within your regions. So thank you very much.